Okay, this lab is wiring a primary control, which you see over here, and an aquastat. In this case, it's a hydrostat, and a switching relay. And in this case, it's a Honeywell switching relay. This is the wiring in the back. I think this model is R859. And if you follow up the wiring, you will go with the, if you see the beginning here with the fuse, the hot wire is going through the fuse. That's the hot, and the neutral is going all the way. We go through the safety switches, the firematic. And if we look at the operation here and how does it connect, the hot wire connects through okay, I'm gonna give the camera to the hot wire will connect here through. It's gonna power the terminal 3 and 5 in the switching relay. It will also power the L1 in both the primary and the aquastat. So be aware of that. The neutrals always have to connect back together. So we designated the light bulb for the ignition, for the motor, the pump, the circulating pump, and the oil valve. This is the circulator that's controlled by the aquastat, and this circulator is connected by the switching relay. So we're assuming here that we have hot water system with two zones, two thermostat, one in one room, thermostat 1 and thermostat 2. Thermostat 1 will control one zone through the aquastat, and thermostat 2 will control another zone, let's say second floor, with its own pump. So now we're controlling and zoning using pumps. And if you notice here, this has to be jumpered, so the control coming to the primary is through the B1, which will tell it to turn on. So the primary usually control itself or turn on by using the thermostat or the B1 terminal. So in this case, it will control by the aquastat. And this is my cat cell control. I'm going to disconnect it to simulate failure of flame. So or there is no flame status here because it's not connected. I have some hot water here to heat this sensor. It is at 160, and our low limit here is at 130. The high limit is at 190. I'm going to turn it on and see it work. First, you go, since the voltage, so the voltage is going through, that's fine. Keep going, and you see the board is being powered, and the aquastat here is on standby. It's on standby because it's not calling for heat yet. So now it says it's calling for heat. Ignition is on, motor and oil valve. It should proof flame within 15 seconds. If you look here now, it says that around 1000 ohms. That's the light we're getting from the room. If it gets close to the light, you can see it is getting less resistance. So ignition is dropped, motor and oil valve are on. So fire is in the combustion chamber. I'm going to simulate that I'm heating this water. It's at 67 right now. If I heat it up a little bit to 120, I should be able to turn on. I'm going to keep this one off. One zone should be turning on the pump. We had an issue with thermostat connection, but things resolved. So you can see the water temperature being sensed over here. It's going up. Once it reaches 120, I think with 5 degrees differential, it should click, and you will circulate hot water to wherever you want it to be. See, I heard the relay should come up. So the pump came up. So now we are circulating hot water through wherever we want it. If the second zone asks for heat, the switch relay will click, and you heard it probably loudly click, and you have hot water going through the second zone. And this is zoning using, again, pump. You can zone using valves. We have a take relay, but this is a simpler one if you just want to add one zone to your house. And I'm gonna play with the high limit here. It's at 190. I'm gonna put it at 150, and I want to see the things stop working. So I'm gonna go at 150, and once it's 160. Yeah, see, it's shut off the ignition and light, and it should shut off completely the light. So now the water is between the two limits. The primary is shut off. We don't need fire anymore. The water is hot. So I'm going to circulate water until this is satisfied. When this is satisfied, it's going to shut off this ignition, And probably see I drop below, it's dropping quickly because it's outside and probably it's evaporating. So this is what's happening. So it's going to call for heat again. Again, this is supposed to be inside the water tank, so it should not be heating this quickly. But you get the idea. So things to think about all the hots and all the moisture should be connected to each other, and this should be covered in real life. But now I just want to see all the balls connected